Okay, so hopefully you remember from geometry that there are two special right triangles that have isosceles 45, 45, 90, and that the ratio of the sides there are the short sides are both 1, and then the hypotenuse is the square root of 2. And then there's also a 30, 60, 90 special right triangle, and the littlest angle makes the littlest side, so the 1 is across from the 30 degrees. The biggest angle makes the biggest side, so the 2 is across from the 90 degrees. And the 60 makes the medium side, which is the square root of 3. So we're going to use those to find some sine, cosine, and tangent ratios. So let's relabel the picture up here. Across from the 30 goes the 1, on the hypotenuse goes the 2, and across from the 60 goes the square root of 3. Across from each 45 goes 1s, and the hypotenuse is the square root of 2. All right, so you can make quick ratio calculations using these. The sine of 30 is the opposite, which is 1, over the hypotenuse, which is 2. The sine of 30 was 1/2. The tangent of 45, doesn't matter which 45-degree angle you look from, it's the same. Opposite over hypotenuse. Opposite is a 1. Opposite over adjacent. Adjacent is a 1. So tangent of 45 is 1 over 1, which is 1. Cosecant of 60. Okay, cosecant, we have to remember, is the opposite of sine. So this is going to be sine of 60 flipped over. Okay, so sine is opposite over hypotenuse. So from the 60-degree corner, the opposite is the square root of 3, and the hypotenuse is the 2. So then we have to flip that over. So it would be 2 over the square root of 3 as the final. Secant. Secant, remember, is cosine flipped over. So this would be cosine of 45, and then we're going to flip it over. All right, cosine is adjacent over hypotenuse, so of a 45-degree angle. The adjacent would be 1, the hypotenuse is square root of 2, and then we're going to flip that over, so it would be square root of 2 over 1, which is square root of 2. Okay, cosine of 30. Again, that's adjacent over hypotenuse. So this time, we have to look from the 30-degree corner. Adjacent is square root of 3. Hypotenuse is 2. Or cotangent. This one is cotangent of 60. So we're going to look from the 60-degree corner. So we're going to have tangent of 60, but then we're going to have to flip it over. Alrighty, so tangent is opposite over adjacent. So the opposite of the 60 is the square root of 3. The adjacent is the 1. And so when we flip that over, that's 1 over the square root of 3. Okay? All right, so now let's put it together with reference angles and angles in standard position. If we draw each angle in standard position, and then we identify the reference angle, so 120 in standard position would be bigger than 90, smaller than 180. The reference angles between where the angle stops and the x-axis, and we can figure out how big it is. The x-axis is 180, where it stops is 120, so that's a reference angle of 60 degrees. Oh, so we can use a 60-degree corner there, or a 30, 60, 90 triangle in that corner. Okay, so if this reference angle is 60 degrees, we're going to put 60 right here. Across from the 60 would be the square root of 3. The hypotenuse would be the 2, and the 1 would be the adjacent. Now, in this situation, since we're in a different quadrant, we always have to look and see if we need to add any negatives. Since we went 1 to the left, this 1 down here should be negative. Okay, and that would complete our picture. We could then answer the sine, the cosine, or the tangent of the angle 120 degrees by using that triangle we just drew. All right, let's try again with 315. 315 in standard position is bigger than 270 but smaller than 360. To figure out how big it is, we could subtract from 360 and figure out that it's 45 degrees. So this is a 45-degree reference angle right here, which means this is a 45, 45, 90 triangle. The 90 is right here. So this is our 1, and the hypotenuse is the square root of 2. If we look at the picture and see if we need to add any negatives, this 1 is positive because it went to the right, but this 1 went negative, or went down, so that's a negative direction. We do need to add a negative there. Hypotenuses are never negative. They're always distances from 0, and distances are always positive. Okay, here's a couple more just to get used to it. Okay, 135 is bigger than 90 and smaller than 180. So how much bigger? We'd have 180 minus 135. So we have a 45-degree reference angle. So this would be a 45-degree reference angle right here. Create that right triangle. And we could tell that that needs to be the 1, 1, square root of 2 special right triangle. And then we look and see if we need to put any negatives. Since this went to the left, that 1 needs to be negative. Since this went up, that's positive. Hypotenuse is always positive. Okay, 390 is bigger than 360, so we need to subtract 360 and find out that we're going around the circle once and then 30 degrees extra. So in quadrant 1, we go around and then a little extra. So we are 30 degrees away from 0 when we start here, so our reference angle is 30 degrees. We drop that down and we have our right angle. And we need to put the 30, 60, 90 triangle in. Now that's always a little harder to do because you have to remember which side goes across from the 30. The smallest side goes across from the 30, so that's going to be the 1. The hypotenuse is 2 because that's the biggest side. And then across from the 60 goes the square root of 3. Since these measurements went right, that's positive, and up, that's positive, so we don't need any negatives on this picture. So now that that triangle is drawn, you could be asked any follow-up question about what's the sine of that 30-degree angle or the cosine of that 30-degree angle. And you would really be answering the question for the 390-degree angle that you drew in the beginning. So if you have questions, please ask in class.